Okay, we'll probably need a couple pages to do all these, but we'll just kind of come back and forth. Some things that are really important to keep in mind in this one. There's log base A of B equals X. Okay? If that is given to you, then you can always change the way that looks. Remember, A is a base, so that starts the wheel. This is kind of like how I remember it. That's the same thing as A to the X power equals B. That's one thing you're going to need to know for a lot of these. Okay, another thing you need to know is that log base A of B, remember A is the base, is the same thing as the log any base of B divided by the log any base of A. You could also call that the natural log of B over the natural log of A. The bases do not matter, and so those are the two facts you need to kind of keep in mind when you're doing these problems. So if you look at A, you're going to change that into something you can solve using the little wheel. So you'll do X to the fourth equals 81. Now, I don't know if this is a calculator. I was assuming you can use some type of calculator. So to get rid of the fourth, you take this to the 1/4 power. But if I do that, I got to take that side to the 1/4 power. These two things cancel each other. So X becomes 81 to the 1/4 power. And if I put that in my calculator, it's asking what number when you multiply times itself gives you 81, and that's going to be 3, right? 81 to the 1/4 power, and the X is 3. Okay? All right. Part B. Okay? 16 to the X minus 1 equals 8. Well, now we're going to go the other way. Okay? 16 is the base. So I'll change my color here so you know which one's part B. So now I'm going to say the log base 16 of 8 equals X minus 1. Okay? Well, this is just the ln of 8 divided by the ln of 16. That's something I can get from my calculator. I have to think you're going to be able to use a calculator on this, because I wouldn't be able to really tell you how else to do this, although I'm sure there's a way. Divided by natural log of 16. I think this is 0.25. No, sorry, 0.75 equals X minus 1. So add 1 to both sides, and X is 1.75, or 1 3/4, or 7/4. Okay? All right, part C is a totally different type of question. So, I'm going to clear this. No, yeah, you can always rewind. This is a video. I'm going to clear this space. Okay, now, remember that absolute value is measuring magnitude or distance away from 0 on the number line. So, just remember that if the absolute value of X equals 4, this is a two-scenario problem. X could equal 4, or X could equal -4. And I think you probably understand that, but that's the concept that you've got to use to solve these questions. So, what we have here is the absolute value. So that means X squared minus 26 could equal 10. Or X squared minus 26 could equal -10. Those are the two options. So we're just going to solve both of these things. Add 26 to both sides. You get X squared equals 36. So X is plus or minus 6. Okay? Add 26 to this one, and you get X squared equals 16. So here, X is plus or minus 4. Okay? So the answer to this question is there are 4 answers. X equals 6, -6, 4, and negative 4. Okay? Okay, similarly, as I change colors here, you get the absolute value of negative 3x plus 1 is less than 2. That means negative 3x plus 1. Okay, well, how can the absolute value of something be less than 2? Well, it could be less than 2, or, if you think about it, it could be greater than negative 2. Let me just go to a new page and explain that to you. If the absolute value of x is less than 2, okay, well, this one won't work. 2 is not less than 2. Negative 2, the absolute value of negative 2 is positive 2, and positive 2 is not less than 2. But this will work. 0 is definitely less than 2. 1 is definitely less than 2. If you do the absolute value of negative 1, you get positive 1, and that is still less than 2. So anything in here will work. So this leads you to x is greater than negative 2 and less than positive 2. So hopefully now you'll be able to see that this is what we've done. We've got to switch signs. Okay? Maybe it would make more sense if I switched. Here, let me write this like that. It's less than 2 or it's greater than negative 2. So I've kind of taken this dual inequality and split it up with an or. Well, now I just solve this thing like normal. Negative 3x is less than positive 1. Divide each side by negative. When you divide each side by a negative, remember you got to switch the sign. So x is greater than negative 1/3, or, let's solve this one. Subtract 2, you get negative 3x is greater than negative 3. Divide each side by a negative 3, you get x is less than 1. Or x is less than 1. So you might be better off writing this like x is bigger than negative 1/3 and less than 1. And how did the answer get written? And the answer just like that. Okay? All right. We're on to E. X plus the square root of 2x plus 6 equals 9. E. X plus the square root of 2x plus 6 equals 9. Well, keep in mind, to start this, 2x plus 6 has got to be positive. You cannot take the square root of a negative. So that means 2x is greater than negative 6. Divide each side by positive 2, so I'm not going to flip my sign. X has got to be greater than negative 3. We're going to keep that in mind, and we're going to solve it. Okay? Here's the easiest way to solve this in my mind. I don't know if, different mathematicians work differently. I don't even know that I am a mathematician, but this is how I would do this. I would get it like that, so I subtracted x from both sides. Now I'm going to square both sides. So you get 2x plus 6, just like we were talking before about cube roots. The square root of something squared, those two operations cancel each other. That was the whole point. Now, 9 minus x squared, I'll rewrite as 9 minus x times 9 minus x, because if I don't, you're going to tell me it's 81 minus x squared. Maybe you're going to tell me it's 81 plus x squared, and you'd be wrong either way. 2x plus 6 is 81 minus 18x plus x squared. I had to FOIL that. Okay, so then you get 0. I'm going to solve this to get everything on one side here. So 0 is 81 minus 6 is 75. Excuse me, long day. Subtract 2x, so minus 20x, and then plus x squared. Let's rewrite that in standard form. So it's x squared minus 20x plus 75. So we're looking for two numbers that multiply to be positive and add to be negative. So they've got to both be negative, and I think that is 15 and 5. So that means x is 15 or 5. Okay, now, when we're dealing with questions like this, both of those satisfy our requirements here, but you're going to want to test your answers, because I can tell you that one of these answers is not correct. Okay? So if I go back up and put 15 in to my original equation, I get 5 plus the square root of 36 is 6. And does that equal 9? No. Okay, so when we squared both sides right here, we did some funny math, and that is what caused this to be, I don't know what the term for it would be, but it's a solution that appears to be a solution, but it does not satisfy the original requirements. Okay? And that's because we squared both sides. But if we check 5, you get, oh, sorry, this should have been a 9. No, I'm sorry, this should have been 15 plus 6. It would have given you a 21. It still doesn't work, okay? We need it to give us 9. So let's put in a 5. You get a 5 plus square root of 16. That's 4, and that does equal 9. So 5 is your only answer, okay? Moving on to F. 2x minus 3 times 3x plus 2 is negative. Whoops. 2x minus 3 and 3x plus 2. Okay, read that exactly how I read it before. Let me just make sure I copied this problem down right. Minus 3 plus 2. Okay, so we want the answer to this multiplication between these two polynomials to be negative. Well, how do things end up being negative? Well, either 2x minus 3 is positive and 3x plus 2 is negative. So one's positive and the other's negative. Or you could say that in blue, maybe 2x minus 3 is negative, and 3x plus 2 is positive. The only way you can multiply two things together and have the answer be negative, it was negative, right? Yes. Is to have one be positive and the other be negative. So let's solve these things separately. So for this one, you get 2x is greater than 3, so x is greater than 3 halves, or 3x is less than negative 2, so x is less than negative 2/3. So x is bigger than 3 halves. Sorry, this shouldn't be an or. This is not an or. This is an and. Because both those things have to happen in order for the answer to be negative, okay? So an and. So can x be bigger than 3 halves and at the same time be less than negative 2/3? I don't think so. Okay, so let's try this one. Just to explain that a little further. How can x be bigger? Here's 0. Here's 3 halves. How can x be bigger than 3 halves and at the same time be less than a negative 2/3? X cannot lie on both those spots at the same time. So I think these are thrown out. Okay? So let's test this one. Maybe it's 2x is less than 3, x is less than 3 halves, and 3x is greater than 2, x is greater than 2/3. So can x be less than 3 halves, which is 1.5? This should be a negative, and that should be a negative. Okay, here we go. And can x be greater than negative 2/3? Well, here is negative 2/3, and here is 3/2. And can x be less than this one and also be greater than that one? Yes, it can. So this is your answer. Okay? So you would write that like this. X is in between 3/2 and negative 2/3. All right, finally, G. Okay, for G, I've got to show you the answer to this one using a graphing tool. So you got 2x minus 1 over x minus 2 is less than or equal to 2. Okay. Okay, so look, you cannot solve this one because you have to multiply both sides by x minus 2. And that when we multiply by a negative, but we don't know if that's negative, and it becomes very conditional. So the best way to do this is to either graph it or just think about what the graph looks like. So let's graph y equals 2x minus 1 over x minus 2. We're just going to graph that left side and see when is it less than 2. So y equals 2x minus 1 divided by x plus 2 x minus 2. 2x minus 1 divided by x minus 2. Okay, and this is what you get. Keep in mind, there's your 2. And we want to know what values of x give us our output to be less than 2. Well, these red lines represent your output. None of these are less than 2. And all of these points are less than 2. Well, that must mean, if I can zoom back in a little closer, that anything on the left side of this line right here, this asymptote, will work. So that will be for all x values less than 2. And that indeed is the answer. That's the best explanation I can give you for that one. G wasn't a great explanation. I hope the other ones helped. Boom!